It's relatively simple to measure the state of charge of a battery, but why would we want to measure its state of health? You may remember the news of Samsung Galaxy phones being banned by the FAA, and just recently certain electric SUVs have been recalled due to risks of battery fires. It's worth saying that these occurrences are infrequent, but they nevertheless damage the reputation of electric vehicle technology. Looking ahead, if we are able to monitor the state of health of these batteries, we may be able to avert future disasters. CDO2 are designing a magnetic imaging device capable of imaging the magnetic fields generated by electric vehicle batteries using a large array of fluxgate magnetometers. Their prototype device will help battery researchers understand how electrical currents flow through the cells in order to improve battery design and manufacturing processes. But how does this magnetic field information help us determine the battery state of health? The images at the bottom of the screen show a test measurement recently undertaken at the University of Sussex. On the lower left, you can see the design of the measurement, where we have a magnetic camera of 16 pixels being scanned over an electric vehicle battery whilst the battery was charging. As we were taught in GCSE Science, a magnetic field is generated as a current flows through a wire. With our image of the battery's magnetic field during charging, we can then work backwards in order to determine the current that must be flowing within the battery, which is shown in the lower right as the current density. With CDO2's device offering 16 times the pixels of this test measurement, images such as this will be able to be taken in under a second. Any subsequent changes to the current flow within the cell on either short or long timescales will then act as a constant monitor of the state of health and will serve as an early warning system for cell degradation and could even lessen the need for regular service intervals. So what is my role within this project? Whilst the fluxgate sensors being used in the prototype are able to detect large magnetic fields, not much is known about the self-discharge currents that creep through batteries when they're resting, or cell chemistries relaxing after being charged. My project aims to replace the fluxgates with super-sensitive quantum magnetometers, such as those being developed at the University of Sussex, which are capable of measuring fields thousands of times smaller than the sensitivity of the fluxgates allow. Using magnetic images captured by these devices, we hope to measure and better characterize relaxation currents within batteries, offering us new insights into the effect of different charging parameters, or even different battery chemistries on the battery state of health. With the ban on new petrol and diesel cars less than 2 decades away, we must work quickly in order to instill public confidence in the safety of these new technologies. With these magnetic devices able to be installed into electric vehicles and send constant diagnostic details about the battery health, malfunctions due to degradation may become a thing of the past.